What do you remember about this from Algebra 2? Okay, what does composition mean? Making something, or building something up. So in this case, we're doing building up a function. Combining them. So thankfully, it's actually probably one of the easiest sections of this chapter. Is this notation familiar? Okay. So this says f plus g of x. What that means is f of x plus g of x. So in other words, we're adding two functions together. So what do you think this one would be? Yeah. And of course we can do multiplication, f of x times g of x, and division. What's the complication with this one? Yeah. Remember, we don't want it to be undefined anywhere, so we're going to have to put a restriction here. G of x does not equal 0. Yes, what if we had, let's say if we had this one, x plus 5, so this is f of x, equals that, g of x equals x. If we did f divided by g of x, we have x plus 5 over x. Where is the problem point? At 0. So we have to say that g cannot equal 0 because then we have a problem.
But if it was if g of x is x plus 5 and f of x is x, then it wouldn't be negative 5?
Yes. So if we were doing g of x divided by f of x, we'd have x over x plus 5, and we couldn't have f of x equal negative 5. So we want to make sure we put a restriction on that says our denominator cannot equal 0. Because if we do, we're divided by 0 and it's got a problem. So let's see, if we had f of x equals x squared plus 5x, g of x equals 2x minus 7. If I did f plus g of x, what am I going to get? Everybody see that? All we're doing is taking f of x, adding g of x to it. Now, the question, what's the domain of this function? Okay, all real, this one? What's the best this one? Then what would the domain of this one be? Okay, in this case, very nice. All three are polynomials, we get a nice answer. Now we start doing a bit more difficult ones. Say f of x equals square root of x minus 4, g of x equals, let's just do x plus 1. What would f of x plus, or f plus g of x be? Actually do f minus g of x. What's it going to be?
Square root of x minus 4 minus x plus 1.
Yeah. And you can't simplify it. You can just leave it like that. Now, if you want, you can distribute the negative. A common mistake people make, what do you think it is? What? Here's a common mistake people make with it. That. What's the problem? Yeah. So, thankfully, usually pre-cal, we move beyond that type of mistake, but that's a common Algebra 2, Algebra 1 mistake. So, make sure you put parentheses there. What's the domain of this one?
All positive, 0 and 0 and
Okay. Is 4 included? Would 4 be included?
Yes.
Okay, so we can say 4 to infinity. What's the domain of this one? So what's the domain of this one?
4 to infinity.
Okay? So when you combine them, we have to use whatever is most restricted from up here. Now it gets more complicated when we start using multiplication. Let's say f of x equals square root x plus 1, g of x equals, let's just do square root of x, make it more. What's the domain of each of them? Okay, so -1 to infinity. This one? So 0 to infinity. Now if we did this, let's say f times g of x. What are we going to get? If we're multiplying these together, x squared plus x in the parentheses. No, you can't take an x out. If it was multiplication, we could. With addition here in the middle, we can't. Now the question is, what's the domain of this?
0 to infinity.
Okay? Could I plug in -1? -1 squared is 1, plus -1 is 0. So, does -1 technically work in this? Yes. However, this is where we run into complications. Because one of our base functions says we cannot use -1, we have to go with that rule. We have to go with whatever is most restrictive about our domain. So like for our answer domain would be 0 to infinity. Note, -1, -0.5, we could plug in and technically we get an answer, right? Yes?
Yes.
We don't get imaginary answers. However, because one of our base functions was more restrictive than that, we have to go with whatever is most restrictive. Because we don't want to say you're combining two things, now we can plug in more numbers. What? Get -2. So -2 squared is 4 plus -2, yeah. Yeah, there's a lot more numbers that would work for this. I don't know about everything. But we have to go with whatever is most restrictive.
And so by that you mean whatever is the smallest domain, like
Yeah, whichever function has the smallest domain or most restricted. Now, let's say this one allowed us to do other numbers, or say this one was excluding x excluding 5. Maybe this was including x does not equal 5, for example. If there was that in here, we would have to say x cannot equal 5 as well in here. So whatever restrictions we have up here, nothing that appears up here, or that's not allowed up here, can be allowed down here. Because we can't combine two functions and suddenly be able to use more numbers. Now, that's even more evident when we talk about division. F of x equals to x plus 2 g of x, x minus 4. Make it simple. F over g of x. What are we going to get?
x plus 2 over x minus 4.
Okay? What's the domain of this one? What's the domain of x? All real. What's the domain of g? All real. What's the domain of this one?
X equals 4.
So x does not equal 4. So our original two functions said we could plug any number in, but if we get connection, we have more restrictions in place. So in some cases, you'll have more restrictions in your answer than you have in your original function. Now, one more type of composition we're doing. So here we had addition, subtraction, multiplication, and division. This one is generally considered a composition or function. Have you seen that notation before? You can read it f of g of x, which means f of g of x. This says take whatever g of x is and plug it into f of x. So if I said f of x equals, say, x minus 7, and g of x equals x squared plus 2x. If I did f of g of x, okay, that means f of, what is g of x?
X squared plus 2x.
Okay, which means we're going to take this and plug it into x.
So x squared plus 2x minus 7.
Yes, x squared plus 2x minus 7. What? Whatever they're at. Okay, so what I did is I took this part right here and placed it inside of x. Remember, when we see f of x, what does f of x mean? Or f of 2, what do we do with the 2? We put in 2 minus 7, right? So this means we're taking all of this whole unit, and putting it in there. Instead of 2, we're putting all of that. How more interesting? G of x. So we're saying it's g and plug g of x into it. What do we need to get with that one?
X squared plus 2x squared plus 2 times x squared 2x.
So I took g of x, which is right here, and plugged it into each of these parts. So this g of x, I took this x right here and replaced it with this whole unit. Took this x, replaced it with the whole unit. Of course, we can simplify it a little bit. Now, how about this? It's g of x of g of 5. Actually, let's make it smaller and make it a bit easier. 2. What does it say to do? So this says first we're taking the 2, plug it into g. What do we get?
2 squared plus, or 8.
Yeah, we get 8, right?
Why do we plug it into g first?
Okay, because that's the last number here.
Is it 8 plus
Then we take 8 and plug it in here, into s. So we right here, 8 minus 7, 1. So now we get 1 here, and we're going to take that and plug it in there. So 1 back into g. 1 squared is 1, plus 2 times 1 is 3. Basically, this is the chain of operations. We're saying, whatever we have here, we're going to plug into the last one here. So here I'm plugging 2 into g. Then I'm taking my answer I get out of g and plug it into s. And taking whatever answer I get out of s and plug it into g again.
How do you know what g is?
Oh, what I know what f and g are? Right there. I still use the same base function.
So you plug into the 2 squared plus 2.
Yeah, the 2 squared is plus 2 times 2. So 4 plus 4, I get 8. So that's where I got this 8 from that I'm taking and plugging into s.
And then 8 minus 7 is
1. And so that 1 is what I'm plugging into g. let's see if we do f of x equals square root x squared plus 5, g of x equals x minus 3. So what am I going to get out of this? Like this. Okay, so I've heard a couple different answers. So tell me what number you're getting.
7G4.
Oh, that's your final answer. What do you get? Okay, she said square root 6. Anybody have a different answer? Anybody else get square root of 6? So you got 1, 2, 3, 4, 5, 6. So you can test it. Okay, so this is 7. Plug it into G. 7 minus 3.
4.
So now we have 4 that we're doing this to. Plugging into G.
1.
4 minus 3 is 1. They're plugging 1 in here. 1 squared is 1. Plus 5 is square root of 6. How about this one? Let's see. G of G of G of G of, let's just do 20. What is this going to do each time? So if I plug in 20, what am I going to get? 17, then 14, then 8. So all we're doing is we're repeatedly plugging something in. Now, how if I did m? What am I going to get? Okay, so we're going to m minus 3, and then m minus 3, or sorry, m minus 3 minus 3 minus 3 minus 3.
Would you simplify that?
Yeah.
How?
Yeah, no, it's because it's only subtraction here. There's no multiplication. We can just do m minus 3. Minus 3 is negative 6. So m minus 12. So this is equal to m minus 12. And so what we got when we plugged in 20 was 20 minus 12 is 8. Now, how many of you have taken chemistry or are taking chemistry? What can you tell me about temperature conversion? Like, you know, the formula. So, Fahrenheit to Celsius. The 5 9 and 9 6. Let's do C of S. And what about K of C? So this one we can say C plus 273, right? Or is it 273.15 or something like that? Okay. So what's the formula up here? Let's see. There's 2 different options. If you have 5 9 or S minus 32. There's one option, and the other one is 9 5 S plus 32. So way to test it. If we plug, what's 32 Fahrenheit in Celsius? 0. 32 minus 32 is Times 5 9? 0. Okay, so that works. What's the boiling point of water in Fahrenheit? 212. And what is it in Celsius? So 212 minus 32, you get 180 times 5, or 180 divided by 9 is 180 divided by 9 is 20, times 5 is 100. So this is the correct formula. But now, if I want a formula that converts me directly from Fahrenheit to Kelvin, I need K of C of F. So taking my F temperature, plug it into Celsius, change it to Kelvin. So what am I going to get? Okay. Well, F is our variable. So this says we're going to take C and plug it into K. So taking all of this, plug it in there. So you have 5 to 9, F minus 32 plus 273. This formula would take us directly from Fahrenheit to Kelvin. Of course, we could simplify it a little bit, but not a huge amount, unless we want to deal with 5 9 times 32 and adding 73 to it. So this homework should be fairly simple. A lot of make sure you follow the instructions though, because a lot of them are asking what is the domain of the function going to be. Let's see if I do another one of these. F of x equals square root of x plus 2, g of x equals x minus 5. And I did f of g of x. What am I going to get for f of g of x?
X minus 5, and then x minus square root of x minus 5 plus 2.
Okay.
Difference.
So minus 5. That's just what a parentheses actually do anything for us. So you could put this here, but it doesn't actually gain anything. So what am I going to get? Okay. So if we talk about the domain, what's the domain of this one? Negative 2 to infinity. What's the domain of this one? Okay. What about this one? So this one says 3 to infinity. So which thing do we use for the domain? This is the most restrictive one, because I couldn't allow negative 2 to be plugged into this one, into my answer here. What would happen if I allowed negative 2 to be plugged in? I get an imaginary number. So we have to go with the most restrictive out of everything. Yes. This one is the key one. If there's something in the domain of this one, or not in the domain of this one, that isn't the domain of any of those, you have to go with this. Okay, remember when we did the division one here? See, where was the down here? No. Down here, these ones, both these had all real as available. This one, we immediately said we couldn't use 4, therefore this is what we have to go with. Because these ones are, we just got to use 4 here.